So let's start. Hayden, my friend. Unit 2, displacement and average velocity. In physics, it turns out that every measured quantity is either, try that again, is either a scalar or a vector. One of the things you will have to memorize, and it'll be worth it, is whether something is a scalar or a vector. In fact, anytime that I give you something new, I'm going to tell you scalar or vector. Okay? Scalars have magnitude only. All they have is a size. A good example of a scalar is mass. What's your mass? 31 kilograms, 82 kilograms. Just has a size. So for example, M equals 85 kilograms. Vectors have both magnitude and a direction. Velocity is a vector. Force is a vector. Direction, if it's a vector, makes a huge difference. So, for example, we'll use force, put a little half arrow above it, and I'll explain to you what that means later if you don't know. The force might be 15 newtons at 30 degrees west of south. And we'll talk about, that's an S. We'll talk about how you give directions in that form later on this year. And you would read that in English, 30 degrees west of south. West of what? West of what? One more time. West of what? To draw that, you would go south, and then how many degrees west of south? West is that way. That's 30 degrees west of south, something like that, as a picture. We'll do that properly later. So let me give you some examples. Speed. Who remembers from Science 10 what the vector version of speed is? Begins with letter V. Velocity. Now, by the way, Cam, there's different ways to show direction. We won't get this advanced. For the longest time, we'll show directions by just using positives and negatives, where negatives will mean backwards or down or south or left or something like that. Mass. Force. Time is a scalar. Well, I watched the Star Trek episode once, and they went backwards. No, time does not have a direction. It's a scalar. What is a vector? What is acceleration? And then two that are closely related, and unfortunately they both begin with the same letter, so it's easy to mix them up. In fact, Taylor, I've been teaching physics now for over 10 years, and I still mix them up verbally. I guarantee you'll hear me use the wrong word to describe one of these. Distance versus displacement. What a waste of time that just was. Writing out words, we're not going to write out words anymore. For all of these, we're going to pick a letter or a symbol, and we're going to use that as our abbreviation for the rest of the year. And those symbols are such good shortcuts that they're going to be worth memorizing. They're not on your formula sheet. You'll just use them so often that you will memorize them, and it's so much nicer. I don't like, why would I write out the word velocity? How about a V? Note. In a textbook, to show that something is a vector, you write it in bold font, like those two. But it's really hard in your handwriting to make something look bold font versus not. So in your handwriting, to show that something is a vector, That's speed. We put an arrow over it. That's a velocity. That has a magnitude and a direction. Although over the years, Jaden, we've gotten lazy. We don't bother drawing the bottom part of the arrow. It's just understood if you do that, because that way you can do it without lifting up your hand. That's a vector. Okay. Distance versus displacement. Distance is how far an object has traveled. What's the symbol for distance? First, I'm going to give you the proper one, which I hate, so don't write this down. The proper symbol for distance, and it comes from a Latin word, is that. What letter is that? Lowercase s. The problem is that looks too much like a 5. They really love to use that one in Britain, because the Brits did a lot of good physics. We're not going to use it. So even though I've showed it to you, in North America, the convention is we use one of 2 letters. We'll use D for distance. Yay, that makes sense. Or if we're on a piece of graph paper and we're moving left and right, we might use the letter X because we're on a graph and moving left and right. Hayden is like X and Y. I will 90% of the time use D, but you may see once in a while I've stolen a handout from online and that particular teacher or prof uses X. I'm not great at computer graphics. If somebody has a handout with lovely pictures, I often will just steal it from online rather than try and type it up myself. Displacement. That's an object's change in position. Symbol. We have a shorthand symbol for change in. That's kind of a science-y thing. Does anybody know what it is? Yeah. It's called a delta. It's a Greek letter delta. The symbol for change in means that. And so you might see it written like that because it's a vector. But I'll be honest, the one I'm going to use the most is that. Although I'm lazy, because displacement is always a change in, you'll often, Hayden, just see me do it that way, and I drop the change in. It's just certain things, you'll 2 things, displacement and time, because they're always changes in. Technically, there should be deltas, but you'll see over the years, physicists have just stopped writing it in front. It's like, we know it's like putting a plus sign in front of a positive number. I know it's positive without the plus sign. I just need to know whether it's negative or not, so don't waste time writing it. When objects start moving, it's useful to be able to describe an object's location. So to describe a location, use your Sesame Street imagination to imagine that there's a meter stick placed next to the object. The meter stick acts like a number line. Objects to the left of 0, we're going to call those, to the right of 0, we're going to call those positive. Right is that way for you guys on the screen. Yeah. To the right of 0 is positive. Objects to the left of 0 is negative. And by the way, Mason, that's arbitrary. There are going to be a few times where we're going to actually let left be positive because it makes the math so much nicer. In fact, what you're going to find often we'll let down be positive because it makes the math nicer, but that's going to come later. So don't think like it's a rule that that way has to be negative and that way has to be positive. But when in doubt, I'll assume that's what you're doing unless you say different. A bug walks along a number line. It starts at A, walks to B, and then turns around and walks to C. So it does this. If I wanted to draw that, I would probably do something like that. What distance did the bug walk? 14 meters. How'd you get that? Okay. Could you have done it without counting? How? 4 plus 10. Yeah. This okay? It's a distance. I didn't put a vector sign on it. Oh, I also forgot to say, we will go through the test on another day, just not today. So if you're wondering, when will we go through it? We'll go through it. What is the bug's change in position or displacement? Where did the bug start at? Location A. 0. Where did the bug end up at? So probably you can see it intuitively. What do you think its displacement, its change in position is? -6. Just to show you if it was yuckier how you would calculate it, you would say, okay, the change in position is always the final position minus the initial position. That will always work for more complicated stuff. In fact, later on, you're going to see in our notes, we're going to write change in anything is always final minus initial. By the way, what abbreviation am I going to use for the rest of the year for final? Little subscripted f, right? Lowercase f. What abbreviation am I going to use for the rest of the year for initial? Hello? I, okay? And because that might look like a 1, you'll notice with my eyes, I put a little hook and a dot, just so you can tell it's an I, okay? What was the final position? -6. What was the initial position? 0. And that also gives you the answer in meters. What's the negative telling me? Left. You could also tailor, if you wanted to say 6 meters left, I'd take that. Which is less writing, the first one or the second one? Let's go with the first one. Now, if you said -6 meters left, then you'd be saying it was negative left. What do you think negative left technically is? Right, I would quibble with that. I would argue with that. Say, nah. Next page. Suppose that you run along 3 different paths from location A to location B. Along which path would your distance be different from your displacement? I'll give you, let's even say it this way. In which of these, path 1, path 2, or path 3, which of these is showing me a displacement and a distance and they're the same? There's your distance, there's your change in position as well. So the ones that have a different, so here would be your, this would be your displacement, different from your distance, which would be that added together. So that's one path where the distance and displacement are different. And here's another one where the distance and displacement are different. Is that okay? So far, so good. Lots of vocabulary-ish stuff. Example 3. It says, use the number line below to give the positions of the objects. Don't forget units. So what's the position of the heart? If you were trying to describe the heart, how could you describe that? Don't overcomplicate it. 4 what? Units. 4 meters. Positive 4, negative 4? Okay, I'm not going to write the positive. I'll assume it's positive if you don't put a plus sign in front of it. Sure. 4 meters. What's the position of the diamond? -4. What's the position of the cross? 0 meters. So we can use arrows to represent a displacement, and the pointy part of the arrow shows you the direction it was traveling. It tells you that's the final location, and therefore the other part is the initial location. A bike moving along a number line from position of 4 meters to -3 meters. What would the displacement of this bike be? Displacement equals -7. Yes? Units? Now, Boyana, you may be saying, yeah, I can just see, but notice my method of final minus initial works. If you go final position minus initial position, you still get -7. So for more complicated ones, that can bail you out. Or if you don't, James, have a picture in front of you and you just have the numbers. It's final minus initial. Change in anything is final minus initial. So we often use a variable, x or d, to symbolize an object, and subscripts, I or f, to show initial and final. It says, example 4, draw an arrow showing an object that moves from the -4 meter position to the +5 meter position. -4, +5, If I want to, I could put the dots right there, I guess. Draw an arrow. And I might call this x initial or d initial. I'm using both variables to get used to both of them. And I might call this x final. I'd figure out what you meant if you wrote that. What's this object's distance? Sorry? 9 meters. What's this object's displacement? Also 9 meters. And this time I might, when I read it out, say positive 9, just to remind me, Jaden, that I went to the right. But in this case, the distance and the displacement are the same value. Draw an arrow showing an object that moves from the 7-meter position to the 1-meter position. Okay. 7-meter position. Here's d initial. 1-meter position. Here's d final. If you want to use a ruler, you can. If you want a freehand, you can. Just try and be straight as possible. What's this object's distance? Nope. 6 meters. Distance is a scalar. Doesn't care about direction. How far did it travel? 6 meters. What's its displacement? Now I'll go with whatever. Now, yes. Okay. Pause the video for a second. Speed versus velocity. Average speed equals the change in distance over the change in time, where delta equals change in. As an equation, we write this. Our symbol for speed is v. I thought that was velocity, Mr. Dueck. Nope. How can I tell that that's speed and not velocity? If it was velocity, what would I have put also on here? Little arrow for a vector. Okay, so speed. There's a fancy symbol for average. I'm just going to go like this, VAV or VAVG. Is that okay? Equals change in distance over change in time. I think that's on your purple sheet on the front page. Can you check for me, Hayden? Somewhere there, I think. Right, there, yep. Okay. To take the average of something, it's actually a horizontal bar, but in small font, that looks too much like that, so I avoid it in physics. There is one, though. Okay. Although I think on your formula sheet, do I have the triangles? As I've said, certain things, because there are always changes in Hayden, we get lazy, we stop putting the delta in front of them. What would the units be? What do I measure distance in? Meters. What do I measure time in? So it's meters per second. If I could give you one handy-dandy piece of advice, here is something you should memorize. And you should know by now that if I say to memorize something, Taylor, it's worth it because I hate memorizing crap. It's well worth it memorizing what units go with which things. You want to memorize that speed and velocity are meters per second. If you see a number in meters per second, you know it's a speed and velocity. If you see a number in seconds, you know it's time. If you see a number with meters per second squared, you know it's an acceleration. If you do that, that really cuts down on your thinking. It really does. So I am going to encourage you to memorize what units go with which ideas, with which quantities. Speed, scalar or vector? Then we have average velocity. I think you turned the page. Average velocity is, Mr. Dueck, that looks the same as the equation you just wrote. I beg to differ. I don't think it does. Is that distance over time? No, no. It's displacement over time. How do I know it's displacement? Vector sign. Oh, where the delta means. And so as an equation, if I want to find the average velocity, That's going to be VAV with a vector bar. Except look up, I'm going to chuck the deltas because I think that's how I wrote it on your formula sheet. Units, also meters per second. Scalar or vector? I wish there was some easy way, Mr. Dueck, that I could remember that velocity is a vector. Mr. Dueck, is there an easy way that I could remember that velocity is a vector? I got nothing. I'm a lousy physics teacher. Sorry, can't help you. Example 6. That bug that we looked at way back when. If its trip in example 1 took 30 seconds, what's its average speed in meters per second? Okay. That's going to be distance over time. Can you all turn back? What was the distance, not displacement, what was the distance that the bug traveled? 14 meters in 30 seconds, which is what? Go to my trusty calculator. 14 divided by 30. I get 0.466. Oh, wait. How many sig figs? 2. Oh, how many sig figs? Technically 1. Look up. Put a little decimal right there next to the 30. Now how many sig figs is that? 2. I'm dividing 2 sig figs on top, 2 sig figs on the bottom. How many sig figs should I go in my answer? So I'd stop there. Would the 6 stay a 6 or become a 7? Now, I'm not going to take marks off for sig figs for the remainder of the year, but I'll just emphasize it during the lessons. So let's write it to the proper number of sig figs. 0.47 units, distance, meters per second time. What was that? Yeah. Well, no, cockroaches go pretty good. Yeah, maybe a little fast. Maybe it's one of those hairy spiders that moves like the wind itself. You know, those ones that you... Holy... Yeah, okay. What's the bug's average velocity? Mr. Dueck, you wrote the same thing. You're right. That's average speed. Behold. Boom, boom. Now it's average velocity. Just add the vector signs. Mr. Dueck, will you ever take marks off if we don't put vector signs in? Probably not. And if I do, I'll tell you ahead of time whether I will be. But it's a good habit to develop. Is it a vector? Is it a scalar? And be careful. What is its average velocity? Well, what was its displacement? Was it -6 in 14 seconds? -0.43. 30 seconds, sorry. -6 divided by, I was looking at the 14 in the previous question. 30 seconds. Oh, that works out nice. -0.2. By the way, why would that be wrong if I was being fussy on sig figs? If I was supposed to go to 2 sig figs, how would I write that? I would have done that. I'm not going to take marks off, but if you want to add the 0 to say 2 sig figs, sure. Because it did work out evenly. By evenly, I mean it doesn't go on forever. If you ask me what's the single most useful skill I can give you that will cut down on your memorization by about 80%, it's going to be something called formula manipulation. So I wrote here, if V average is distance over time, what would an equation be for displacement and for time? Draw a little line down the middle. Let's put D equals. We're going to do some equation solving. We're going to start with this equation, Tyler. See the D, see the D, see the D? What side is it on? The right side? What else is on the same side as the D? The T. What's the T doing to the D mathematically? Adding, subtracting, multiplying, or dividing? To move it over, I want to do the opposite of dividing by T. What's the opposite of dividing by T? Another equation is that, and I don't have to memorize it. I can derive it in 1 second if I know my equation solving rules. I think in the first unit, I put this one on your formula sheet, but as we get good at this, you're going to see all I do is I give you the one master equation, and I'm going to try and get you, and you will, Brendan, get very good at rearranging them all in your head. And if you get that skill, it means you don't have to memorize a bunch of extra equations. You just have to know the one from the sheet, and you can rearrange it. How could I get the time by itself? You know what? I would start here. See the t? What else is on the same side as the t? What's the v doing to the t mathematically? Adding, subtracting, multiplying, or dividing? How will I move it over? Apparently, time is displacement divided by velocity, and it's average and average. In fact, if you're from Science 10 last year, do you remember in Science 10, what were the units for velocity? Do you remember? What are the units for velocity that I've showed you here? Say it again. One more time, you're right. Say it again. Stop. Isn't meters distance per what? It's actually, the equation is contained in the units. Meters per second, distance over time, that's velocity. And from that I can get all three. A motorist travels 350 kilometers during a 6-hour period. What was his average speed in kilometers per hour and meters per second? So as we get better, you might break away from what I'm about to show you, but I use an approach called DPHIC. It's an acronym. Anytime I come to a new physics question, I DPHIC and I DULP. DULP stands for draw a little picture. DPHIC stands for what I'm about to show you. My physics 12s, they all know, Mr. Dueck, I don't know what to do. Well, DULP and DPHIC, I'll say to them. Start there. And I think I've already done my rant about how it's nice not to have something blank staring you in the face. So part of this includes that. D stands for list your data. We're going to do that over here under example 7. What's example 7 asking me to find? Now, although these are word problems, the nice thing in physics is it's usually pretty easy to figure out what they're asking you to find. It's not like in math where you're like, let x be the number and all that crap. What are they asking me to find? There's a word in front of it. So I'm going to write this. VAV equals question mark. That's my way of saying to the marker or to myself, that's what I'm trying to find. Then I go through the question and I look for numbers and physics words and I look at the units next to the numbers to figure out what they are. And I can do this almost instantly. I glance at the question. I see a 350. See it? What are the units next to it? What do you think that is? You can write kilometers next to there if you want to. For some reason, I tend not to. You can. I see a 6.0. What's that? How do you know? What are the units next to it? It's worth memorizing what units go with which stuff. It really cuts down on your thinking when I'm introducing brand new stuff to you as well. Hopefully, by the end of the year, you'll glance at things. Oh, of course I know that's a force. Oh, of course I know that's momentum. Oh, of course I know that's energy, just by the units. So symbol for time is T. That's the data. That's the D. The F stands for find a formula. I'm looking for an equation that has V, D, and T in it and nothing else. Now, this may seem really obvious right now, but by Christmas, when you've got about 45 different equations, this is part of the skill you're going to build. Right now, I've only given you, Tyler, one equation. It's this one. Right? The I stands for insert the numbers. By the way, do you notice what I did? I listed everything. I wrote down the equation. If this was a test, hopefully now you guys are like, oh, it's no longer blank. I've written something down. I'm more relaxed. Piece of cake. Now it's insert the numbers. And then the C stands for crunch the answer, or calculate the answer if you want. I always talk about number crunching. So crunch the answer. When in doubt, I DPHIC. Now, so there's going to be some questions where you get so good, Braden, and we'll all reach a point where we don't go all this detailed, but in our notes for the first few times so that when you're studying, you know what the heck we did? Sure. If you want to take shortcuts in your homework and you're getting all the right answer every time, I'm okay with that. What is 350 divided by 6? Sorry? 58 even? Wow, that's nice. 58. Is it? No? 58.3333333. Okay. By the way, how many sig figs? How many sig figs? 2. The 0 doesn't count unless there was a decimal there. I'm dividing. How many sig figs? I guess I should go to 2 technically. So I'm going to go 350 divided by 6, and I'm going to say the answer is 58 kilometers per hour. Is that what they wanted me to find? In football, you may have noticed when people score a touchdown, they spike the ball. They do like a touchdown dance. What I do when I've got the answer that they want me to find, there's my touch. That's my eat that, teacher. You know, in your face. Oh, but we're not done. They said find it in kilometers per hour and what? We need to convert this to meters per second. I guess I write down what they give me. And now I'm going to use the full value, the 58.3333333, which is still on my calculator. And this is kilometers. You know what, Mr. Dueck? I need to move this down. I need more room. Per hour. This is the only unit conversion that you are going to do an awful lot for the remainder of the year, but I'm going to give you a shortcut, and we're going to derive it right now. I need to get rid of kilometers, and I need to get rid of hours. I can't do both all at once. Cam, what do you want to get rid of first, kilometers or hours? I don't care. So since kilometers is on the top, on the bottom, and meters can go on the top, and I'm going to replace the K on the top in front of the meters with 10 to the, I think it's 1,000, 10 to the third. Is that a phone? Pause. One of our Timbits. Cam, that would take care of that. Now I need to get rid of hours. Where is hours in my original fraction, by the way? On the, so I want to put it in my next fraction on the, to get it to cancel. And I'm going to go straight to seconds because I know that 1 hour is 3,600 seconds. So it's going to be 58.33, I got it here on my calculator, times 1,000 divided by 3,600. And I get 16.2 meters per second. Mr. Dueck, yeah. So to go from kilometers per hour, you times by 1,000, yeah, and divide by 3,600, yeah, and that'll get you to meters per second, yeah. There's your shortcut. If you combine that timesing by 1,000 and dividing by 3,600, if you want to go from kilometers per hour to meters per second, it's divide by 3.6. Just this once, I will let you put that somewhere on your purple sheet, if you want. By the way, if going from kilometers per hour to meters per second, I divide by 3.6, how would I go the other way, from meters per second to kilometers per hour? So I'm going to put down here an arrow going this way, and I'll put times by 3.6. That one, most of my kids just memorize because you're going to use that about 50 times during this unit. You're going to get sick of looking it up. But what they can't remember, do I divide or do I times? And I will show you a way to memorize that by being clever later. All right. couple more, and we're nearly done. Yep. Good, 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 good. If it seems like I'm going slow, it's because Science 10 has done so badly, I want to repair the terrible damage that they did. Hopefully you're finding, especially if you did well on this in Science 10, kind of, oh, I know this. Good. Hey, the speed of sound is 330 meters per second. In fact, speed of sound is right around 333 meters per second. It's 333, which for me is an easy number to remember. Sheldon is shouting at the base of a steep mountain. Right, Sheldon? If the mountain is 420 meters away, how long will it take before Sheldon hears his echo? We're going to defic. First thing I ask is, what is this question asking me to find? Time. How long? Now, in English, how long is a bad phrase because how long can mean time. But if I say to you, how long was the racetrack, it can also mean distance. If it's a test and I use the phrase how long, I'll try and make very clear what it is. Although, wait a minute, there is a distance in this question, so why would they ask me how long and mean a distance when there's a distance in this question? Okay. So I'm going to write this first thing. T equals question mark. That 330, what's that? So I could write this. What's that 420? What are the units right next to it? Meters. What is that then? So I'm going to write this. Now, this is a tricky question. Oh, I like this question. I like this question. I like this question. Why would I say that? Did you hear me say that? Or your kind of student tends to notice certain things when the teacher emphasizes? Oh, good, 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 good. What is the distance that the sound is traveling to get back to your ears if it's an echo? It's going there, hitting the wall, coming back. So I'm going to write now, someone said 840 and you did it, and that's great. In our notes, just so that when you're studying later, you know what the heck we did, I'm going to write 420 times 2 there and back. So what that means is I'm looking for an equation that has time, v, and d in it. Well, the equation that we've already been using is this one. Except, what do I want by itself? T. Okay, I can do that without having to memorize a whole new equation. Right now, on this side, we're dividing by t. I don't want the t to stay there. I want to move it to this side. To move it to this side, what's the opposite of dividing by t? So right now, cross out the t like that, put a t there. That's the same equation. No, it's not. Yes, it is. Looks different, but I'm telling you, it's the same equation. Have we got the t by itself yet? No. What else is next to the t? What's the v doing to the t? So how could I move it over? If you, I'm going to force you all to get good at this, and when you do, you're going to find this is such a memorization crap saver. Don't memorize useless stuff. So I'm going to go t equals, if I heard you correctly, is that what you're saying? You can memorize that if you want to. But we're going to be getting about 150 equations this year. Knock yourself out. Or don't. Memorize about 15 of them and learn how to derive the rest in your head. What was the distance here? Hayden, what was the distance here?
420.
Don't think so.
Times 2.
In your head, please, without a calculator.
Oh, it's too early in the morning.
That's why I'm picking on you. Or with a calculator, which you have out in front of you, playing along. We'll bail him out. 840. And the speed is 330. Get your calculators out. By the way, every year there's kids who during the lesson sit passively and don't type this in. Type this in. You want to get better and faster at your calculator. Every year, Cameron, I mark kids' tests where they have all the right numbers written and they have the wrong answer. And it's because they were too dumb to follow along during class. They didn't know how to use their calculator. They didn't realize that their calculator, you have to type the thing in a certain way to get the right answer, and they never found out till it was too late. This is fairly basic, I think. I get 2.545454. How many sig figs? I guess technically 2 sig, 2? Yeah, 2 sig figs. So I'm going to go 2.5. You know what? I'll go like this. 2.54 repeating, and then I'll put an equals 2.5 seconds. That's the right answer. There's my touchdown. By the way, you can also use this if you are at an echo somewhere and you have a stopwatch on your cell phone, on your smartphone. If you get T, V is 333, you can figure out how far away the mountain is that you're echoing off of. You can find D. Yes, I do that. I'm a nerd. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel in kilometers and in meters? What's this question asking me to find? Yay, I wrote something down. I feel better. Can anybody see why this question is a little bit yucky? What's that 18? Per? What's the time? Hours. Eesh. Can't do math with hours and seconds in the same equation. So we can either change the 2.5 to hours, or we can change the 18 to kilometers per hour. I'm going to do that one. I'm going to do this. V equals, and this time I will write units down, 18 meters per second. It'd be nice if there was an easy, shortcutty kind of a way that I can go from meters per second to kilometers per... Oh, there was one. It involved a 3.6. Oh, what was it? Do I times or do I divide? I can't remember. What did I write down? Hello. Times? So, 18 times 3.6, 64.8 kilometers per hour. And T equals 2.5 hours. And you'll notice, Cameron, I'm writing units this time because they're yucky. They don't all match. We prefer, by the way, our speeds and our times in meters per second and in seconds, but we can do kilometers per hour as long as everything's in kilometers and everything's in hours. Oh, I'm looking for an equation that has D, V, and T in it. I have one, this one. Except, what would I like to get by itself? How would I get the D by itself? What's that T doing on the same side as the D? Adding, subtracting, multiplying, or dividing. So what's the opposite of dividing by T? So if I hear you correctly, Taylor, you're saying that this equation is also true? And it is. So it's going to be 64.8. I'll use the kilometers per hour one. And 2.5. Conveniently, I have the 64.8 stored on my calculator, so I just use my answer button. Hopefully by now you've heeded my advice and gotten a half-decent calculator. And I get 162 what? Kilometers, not meters. Now that's the answer in kilometers. It also wants the answer in meters. What's the quick way to go from kilometers to meters? You guys picked up on that one? We can do a full unit conversion if you want, but it's times 1,000. So I'm going to also say equals, yep, 162,000 meters. I guess I could have done that in my head. I'll put a box around both of them. Also, Brett, you may notice I ignored sig figs here. I really should have gone 160 and 160,000, but whatever. True or false? An object can have a positive distance while having a displacement equaling 0. An object can have a positive distance while having a displacement equaling 0. True or false? You know what? We're going to vote. How high you hold your hand up is how sure you are of the answer. I'm positive! I'm pretty sure. I'm only voting because Dueck is looking around and he'll make fun of me if I don't have the guts to vote anything. And he will! Positive? Pretty sure? Who thinks the answer here is true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Who thinks the answer is false? So 11 of you didn't vote? You're right in the front row with me, and you didn't vote. True or false?
Let's go with true.
Ten wimps, no opinion. God. So then I always say, you can either convince me that you're right or that someone else's answer is wrong. You can attack or defend. Attack someone else's answer or defend your own answer. Convince me. Give me an example. How can you have a positive distance while having a displacement equaling 0? Really? Yeah.
Similar to what you were talking about before with the racetrack.
Sure. There. Great explanation. D equals whatever, the distance is whatever it is to go around the track. But I'm telling you, if you end up back where you started from, your displacement is 0. And you never went backwards once. Example 11. An object can have a positive distance while having a negative displacement. True or false? Once again, we're going to vote. Once again, how high you hold your hand is how sure you are of the answer. Positive? Pretty sure. Only voting because Dueck will make fun of me if I don't vote. Okay. An object can have a positive distance while having a negative displacement. Who says true? 1, 2, 3. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who says false? 1, 2, 3, 4, 5, 6, 7, 8. God, 9. Boy, we got some wimps here. Once again, convince me. Attack someone else or defend your own. Give me an example. How can you have a positive distance while having a negative displacement, or convince me that you can't? Yeah.
You run around the circular racetrack and stop before the start line.
Ah. Run around circular track, but stop, and I'll use the word behind because that it connotes negative, the finish line. Your displacement would be 3 meters behind the finish line, -3, but your distance would be, if it was the 400-meter track, 397 meters positive. Sure. And I think I forgot to circle true back here. So circle true for both of those. By the way, we're going to go right to the tone, and I'm not going to give you any homework for the weekend. Then next class, when I see you, we'll go over the test. That'll take about half an hour or so, and then I'll give you the rest of the class to finish the homework. So your Thanksgiving present from me is no homework, unless you have NHIs, which many of you do. An object can have 0 distance while having positive displacement. Making you think. An object can have 0 distance while having positive displacement. Once again, we're going to vote. Once again, how high you hold your hand up is how certain you are of the answer. Once again, if you don't vote, Mr. Dueck will make fun of you. True! Is that a hand up? Just adjusting hair number 97? False! Oh, that was, sorry, I couldn't see. Are you, yeah, okay. I can't think of an example, so while that's not necessarily a proof that it's false, I can't think of a way that this could work. So I'm going to go with that. I love Foxtrot comics. Have I done my Foxtrot comic speech with you guys yet? So if you read Foxtrot, which is published in the paper, Bill Ammond, the author, actually has his physics degree. In fact, he was in university, and while he was doing his physics degree, he was often doodling and making little comic strips, and his friends said, you know, those are funny. Why don't you try publishing those? The other reason I love, what I love about Foxtrot is the math and the physics are right, and also I empathize with the young nerdy son named Jason. Go figure. So here it says, Jason and his older brother Peter are playing football. Jason says, okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. Peter does some physics. Won't I be right back where I started? Jason says, I can't throw very far. Okay, here's a new play. I never get to be quarterback. I have run that play one time when it was sunny. We walked out with my class, and we ran it, and it does end up back where you started from. So, what distance will Peter run in order to complete the play? Well, the distance is going to be 40 yards plus 20 yards. That's the first panel. Then 25 more yards, then 30 yards, then 30 yards, then 10 yards, then 15, then 20, and then 50, which is what? I can do this in my head. 40 and 20 is 60, 85, 115, 145, 155, 160, 170, 190, double check me, 240? Yeah? Okay. I can do math in my head. Distance, 240 meters. If he ends up back where he started from, what's his displacement? Mm-hmm. Oh, thank you. US. Yards. You know what? I think yards is actually YA, because a little y I think is years. What will his displacement be? 0 yards. By the way, is what I've written technically wrong? Okay. And again, I won't take marks off for that for a while, but